Okay, so today in this lecture, as promised, we're going to actually analyze a circuit that includes inductors with mutual inductance between them. This is the circuit that we're going to analyze. So let's identify what inductors we're talking about and how they're affecting each other. So there's a 16 Henry inductor down here, a 4 Henry inductor up there, and there's actually a mutual inductance equal to 8 Henry between the two, and that's how the circuit is symbolizing that mutual inductance. In other words, it's showing that these two inductors do have an effect on each other. We explain how, because the magnetic field in one can affect the other one and vice versa. So the approach would be exactly the same as our approach to any other circuit analysis. We're going to first start by labeling the circuit. So we pick this and call it our ground. Then we have this one, I'm going to call it V1T. We had this one in the middle, I'm going to call it V2T. And we have here this last node, and I'm going to call that one V3T. This current obviously is IG. This current passing through this 5 ohm, I'm going to call it I1T. The current passing through the 20 ohm, I'm going to call that I2T. The current passing through the 16 Henry, I'm going to call that I3T. The current passing through the 4 Henry, I'm going to call that I4T. And then finally the current passing through the 60 ohm, I'm going to call that I5T. So we have a KCL for this node, we have a KCL for that node, and a KCL for this node. 3 KCLs. So we're going to write the KCL equations first. KCL for this node, IGT, which is that 16 minus 16e to the minus 5t. That's the equation for that current, right? It says IGT is that equation. Is going into that node, and these two currents are leaving. So that's equal to I1t plus I4t. For this node in the middle, we have I1t going in, and then I2t and I3t are leaving that node. So that's equal to I2t plus I3t. For the node at the end, we have I2t going in, I4 is going in, I4t, this I4t, and then that's equal to I5t leaving that node. Okay, so those equations conclude our KCL equations, and then we move on to the equations for components. Equations for components. We have 1, 2, 3, 4, 5, 6 components. The equation for this one is already taken care of. That's the equation for that component that defines what current is passing through this, because this is a current source. We go through the resistors one by one. For the 5 ohm, we have I1t is equal to V1t minus V2t, V1t minus V2t divided by 5. For this resistor, right there, we have current I2t is equal to V2t minus V3t divided by 20. For this third resistor, we have I5t that's equal to V3t minus 0 divided by 60. 2 more components, the 2 inductance with the mutual inductance. So we recall, now see the current here goes into the dot and current there also happens to go into the dot. These are obviously arbitrary. I chose the direction of the current, but now I'm going to follow the convention that we mentioned. So we said with that, for this inductor, V2t minus 0 at the other end is equal to L, which is 16, di 3t dt, now plus, because the currents are both going into that node, 8 Henry, which is the mutual inductance, times di 4t dt. And then finally, for that inductor up there, V1t minus V3t is equal to 4 Henry times di 4t dt, and again plus the 8 Henry di 3t dt. Okay, so let's count the number of unknowns in the circuit. We have I1, I2, I3, I4, and I5, 5 unknown currents. And then we have V1, V2, and V3, 3 unknown voltages, total of 8 unknowns. And the number of equations, you count them, is exactly equal to 8. In other words, this is a solvable set of equations, and all we need to do is math. Now, for the math, one of the simplest things that we can do to quickly reduce the number of equations from the 8 to something that's much lower is to take the equations for the currents and put them in the equations for the voltages. So what do I mean by that? For example, in V2 here and V1 minus V3 here, we have these I3 and I4. Now, if you notice, I can write I3 and I4 as a function of 2 other currents. For example, I4 is this 16 minus 16 e to the minus 5t minus I1t. And then I1t is a function of voltages. So using this equation and this equation, I can replace replace I4t as a function of everything that is voltage. So this turns into an equation that only has voltages. I can do the same thing for I3, and then once I do that to these two equations, I end up getting equations that are only function of voltages. And with that, then I reduce the number of unknowns from 8 quickly down to 3, only voltages. And once I have that, I can reduce the number of unknowns or equations from 3 down to 2 and 1, and finally get that one differential equation that could be solved. So for that, I need more time and I need more space. So I'm going to stop and then come back and show you how to do the math. Because it takes time, I'm going to write down the math and then go through it together. Okay, like what I said, you can see that from this equation, I can write I4 as a function of something that is only a function of voltage. So what I did is to move I1 to the other side. Then I1 is a function of V1 and V2. I put it there. I can do the same to I3. So I3 is I1 minus I2, and I1 and I2 are function of voltages. So again, I3 becomes something that is only a function of voltages. And then finally, with this one, I can turn this equation to another equation that is only a function of voltages again. So I know I2, how that is a function of voltage from this equation. I know I4, how that's a function of voltages from this equation that I just developed. So that whole thing. And then finally on the other side is I5, and I5 is directly equal to V3 divided by 60. So this gives me an equation that is only a function of voltage. Then I move to these two last ones. So V2 is a function of I3 and I4. I know how I3 and I4 are functions of voltages. So I replace I3 and I4 with their equivalent values as a function of voltage. So I get an equation for V2 as a function of other voltages, V1, V2, and V3, and do the same for the last equation where V1 and V3 on one end is a function of I3 and I4 again, and I told you how we turn I3 and I4 into equations of voltage. So by replacing those, now I have these three equations where I have only voltages in these three equations. So the next step, I know it's a relatively lengthy process, but that's what it takes to do the circuit analysis for this circuit. V3, V1, and V2 exist in that without any derivative, so that gives me an opportunity to find V3 as a function of V1 and V2. Basically, I move V3 to the other side, so that other side becomes V3 divided by 60 plus V3 divided by 20, which ends up being 4 V3 divided by 60, which is V3 divided by 15. So I have V3 divided by 15 on one end, and then I have V1 and V2 on the other end, multiplied by both sides by 15, and I find V3 as a function of V1 and V2. Immediately when I get that, I can then replace V3 in these two other equations, and now I turned my set of three equations to two equations. After that, I take V1 and V2, find one as a function of the other, put it in the other equation. I go from two equations to one, and then I have my final differential equation that needs to be solved. And based on that, since we know how to solve a first order differential equation, I can solve that. I'm not going to do the rest of that here. I really hope you can actually continue that. I'm gonna explain that once more, the process once more, because I have a limited space here, and I need to clear something, and that kind of removes the continuity. So again, here I have three equations and three unknowns. From the first equation up here, I find V3 as a function of V1 and V2, put it in the other two. Then I have two equations and two unknowns. I take one of the two, find V1 or V2 as a function of the other, put it in third equation, and I end up getting one equation, one unknown, in the form of a differential equation that needs to be solved. Once I have that solved, then I go back and just keep calculating every unknown. Once you calculate one, the rest, it becomes really easy to do. Thank you very much for the attention. We're done with this topic of doing mutual inductors. The next topic would be an extension of mutual inductance, which is the concept of transformers. Thank you.